Chapter 4, Lesson 5 is on multiplying polynomials. So the first thing we want to know is, does 3 plus 4 squared equal 3 squared plus 4 squared? Now, when we were raising powers to powers and products to powers, and we had a squared outside, it did come in, and that did equal 3 squared x squared. However, when you have that addition, or if you have subtraction, no, it does not. We don't bring in the squared. 3 plus 4 squared is 3 plus 4 times 3 plus 4. Another way to look at it is to say 7 squared, which is 49, or 7 times 7, which is 49. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So you can see they don't equal each other. So there are two ways to work this out. We can use the FOIL method, which is probably the most common method, or we can use the table method. FOIL stands for first, outside, inside, and last. And this tells you the order to multiply things. So if we're doing FOIL, we'll write those out. X minus 3 squared is x minus 3 times x minus 3. And first, x times x is x squared. Oh, I should have written that there. Hold on. Magic, it never happened. Okay, that's x squared. Outside, x times negative 3 is negative 3x. Inside, negative 3x. And then last, negative 3 times negative 3 is positive 9. Now I have two like terms, so I add those together. And I get x squared minus 6x plus 9. Now the table method is a little different. With the table method, you're actually going to make a multiplication table. So I'm still going to have x minus 3 times x minus 3. What I'll do is I'll make a table. I have x minus 3 and x minus 3. And I do this just like a multiplication table. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. And when you do this, your like terms line up on your diagonal. And so I have x squared minus 6x plus 9. So you see, you get the same answer no matter which method you choose. It's just to pick the one that makes the most sense for you. Now I will say that when we multiply longer polynomials, the table is a little more user-friendly. So let's do some more examples. Again, I'll use both FOIL and the table, so you can pick which way you like better. And in both instances, we're going to have 7x minus 8 times 7x minus 8. For FOIL, I multiply first, outside, inside, and then last. And then I add my like terms. And I'm good to go. With the table, make a table. And this time I'm going to go ahead and write it. 7x times 7x is 49x. 7x times negative 8, 56x. Negative 8 times 7x is 56x. And 8 times 8 is 64. My like terms are on my diagonal. Oops, right, there should be a squared there. and I get the same answer. Again, you can pick the method that makes the most sense for you. Okay, one more squared. X minus 5. Oh, sorry, this is a cube. Okay, when I have a cube like this, I can only multiply two together at once. So, I'm going to FOIL the first part, and then I'm going to table the second part. So I'm going to FOIL this first part first, outside, inside, last. So first, I get x squared, outside minus 5x, inside minus 5x, and last is plus 25. And that's still going to be times x minus 5. I can't lose that last x minus 5. Add my like terms, I get negative 10x times x minus 5. Now I'm going to multiply this with the table, and here's why. When I have a table, and I have more than 2 by 2, it can get really complicated with FOIL, but with a table it's very nice and organized, and I'll show you the difference down here. X times x squared gives me x to the third. I get negative 10x squared multiplying these, and then 25x. And when I move down, I get negative 5x squared, 50x, and negative 125. And again, my like terms are still lining up on diagonals. Negative 5 and negative 10 is negative 15. 50 and 25 is 75, and then minus 125 at the end. Now let me show you the difference between the table method for the 2 by 3 and the FOIL method for the 2 by 3. I have to multiply each of these by 3. 3x. So I get 12x to the third minus 15x squared plus 9x. Then I multiply each of these by negative 4. With a 2 by 3 it's not terrible, but when we get down here to this 3 by 3 it gets kind of hard to keep track of. I have negative 16x squared, 20x, and negative 12. The other thing, my like terms aren't right next to each other. That's not such a big deal, but it's more convenient when they are. So I get 12x to the third minus 31 x squared plus 29x, and then minus 12. Now on the table, we get all the same information, as you can see, but my like terms are going to be right there on diagonals, but I will get the same final result. So you can pick the method that makes the most sense for you. I'm going to go ahead and write this out for the table. And it doesn't actually matter which one you put across the top or which one you put down the side. I usually do the longer one across the top and the shorter one down the side just to make it take up less room, but it really doesn't make a difference one way or the other. Okay, if you're doing kind of the FOIL method for a 3 by 3, it's not really FOIL because it's not first outside, inside, last anymore. It's each thing times every other thing. So I have those to multiply, and I'll have these to multiply, and then I will have these to multiply. And if you miss any one of those, you've got 9 things there, you'll get the whole thing wrong. So 3x squared and 2x squared is 6x to the fourth. 3x squared and negative 3x is negative 9x to the third. 3x squared and 2 is 6x squared. Then negative 2 times 2, negative 4x to the third. Negative 2 times negative 3 gives me 6x squared, and negative 2 times 2 is minus 4x. I ran out of room, so I'm going to come down to the next line. 10x squared minus 15x and plus 10 was when I multiplied everything by 5. Now I've got all that, and I need to get my like terms. 9 and negative 4, x cubed, 6 and 6, x squared, and then I have negative 4, ooh, see look, I missed that 10, so that's 22x squared instead. See, 1 cubed, 1 cubed, 1 to the 4th, 1, 2, 3 squareds, 2 x's, and then that 10. So you can see it's kind of easy to make mistakes. If I have the table, that's 10x squared, negative 9x to the 3rd, 6x squared, 15x, 6x squared, negative 4x, and 10. And you can see here, I wouldn't have made that mistake of missing that 10x squared because they're all lined up on my diagonals. 9 and 4, 6, 6 and 10, negative 4, negative 15, and then 10. So it's a matter of preference. One way is just as good as the next. All right, let's take this into some word problems, which I know everyone loves. Okay. The formula for the area of a square is a equals x squared, where a is the area and x is the length of a side. If the length of the square is increased by 3 and the width is reduced by 4, what would be the area, the formula for the area of the resulting rectangle? Okay, so we started out with a square and each side was x. Now, one side is going to be increased by 3. The other side is going to be reduced by 4. And to find the area, I multiply those together. And I can use FOIL or a table. Either way, I'm going to get x squared minus 4x plus 3x minus 12. So that's first, outside, inside, last. Or if you make the table, these would be in your diagonal. Add the negative 4 and the 3 together, and you get x squared minus x minus 12. Drawing the picture on this will really help. Okay, here, if we added 2 inches to the length and 4 inches to the width, what would be the area for the new object? So again, we have a square. We're going to add 2 here, and we're going to add 4 there. So I have x plus 2 times x plus 4 is equal to the area, and for this one I'll make the table. So I get x squared, 2x, 4x, and 8. I add my like terms together, and my new area would be x squared plus 6x plus 8. Let's try another one. Okay, a piece of cardboard measures 16 by 18 inches. Okay, so I'm going to draw that. Here's my cardboard, and I have 16 by 18. If squares are cut out of each edge of the cardboard, and the sides can be bent up to make a box. Okay, so I'm going to cut out these squares. And then this would get folded up here, 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 and here. Okay. What would be the area for the volume of the box? Now, I don't know how much I'm cutting out, so I'm going to call that x. And they're squares, so both the length and the width of those squares would be x. So my new length, well, here, if I brought this box up to the sides, the fold would be x, would be the height. My new, my new length would be 18 minus 2 of them. And my new width would be 16 minus 2 of them. So my volume is length times width times height. So that's going to be 18 minus 2x times 16 minus 2x times x. So I'm going to multiply the x times this one first because that's just going to be easier. And I'll get 16x minus 2x squared because I brought this x in. Then I can make a table or I can do FOIL. I'm going to make a table. Or you can FOIL, either one works. 18 times 16 I did not memorize, but it is 288x. 18 times 2 is 36, so I have negative 36x squared. Then I have negative 32x squared, and then 4x to the third. Now I'm going to rearrange that, and my volume is going to be 4x to the third minus 68x squared plus 288x. So that'll be the formula for the volume. Now we're going to complete the table to find the volume if this is the length of the square cut out. So if it's 0, well, my volume is 0 because I'd be plugging 0 in, 0, 0, 0, 0. Okay, if it's 1, I'd have 4 times 1 cubed minus 68 times 1 squared plus 288 times 1. So that would be 4 minus 68 plus 288 would give me 224 cubic inches. If it's 2, that's third, 2 squared plus 288 times 2, that's going to be 4 times 8 minus 68 times 4 plus 288 times 2. And when I work that out, I get 336 cubic inches. And if the thing was 3, plug in 3. And 3 cubed is 27, so I'd have 4 times 27 minus 68 times 9, which is 3 squared, plus 288 times 3, which will give me 360 cubic inches. So you see, taking an inch more off the square doesn't really change the volume all that much. But changing between the 0 and the 1 was pretty big, and then changing between the 1 and the 2 was actually pretty big. So which size square would maximize the volume out of these? It's going to be 3. That gives us the highest volume. Okay, well, we've multiplied polynomials. So the next thing to do, sorry about that, is to divide polynomials. So dividing by a monomial, we're going to do this as a fraction. When you have a monomial, it's the easiest way to do this is to rewrite it as a fraction. So what I'll do is I'll come in and I'll rewrite this. All over 2x squared y. Now, what I'm going to do is I'm going to reduce each of these by the 2x squared y. So 8 divided by 2 is 4. 4 minus 2 is 2. 3 minus 1 is 2. Then I go to the 16. 16 divided by 2 is 8. 3 minus 2 is 1. 2 minus 1 is 1. Then I go to the last term. Negative 2 divided by 2 is negative 1. 2 minus 2 is none. 1 minus 1 is none. And there's my final answer. I've divided. So let's try another one. 24x to the third y squared plus 12x squared y to the third minus 9xy squared plus 3x. all divided. 3 minus 1 is 2. 2 minus 1 is 1. 12 divided by 3 is 4. 2 minus 1 is 1. 3 minus 1 is 2. Negative 9 divided by 3 is negative 3. 1 minus 1 is none. 2 minus 1 is 1. And then 3 divided by 3 is 1. 1 minus 1 is none, but then I have this y left that I had nothing to divide it by, so it stays in my denominator. It's kind of like a remainder. It didn't cancel, so you keep it down in there in the denominator. Okay, the next thing is if we're dividing by a binomial, and this one we can't write as a fraction. So what we're going to have to do is what's called polynomial long division. And we'll do polynomial long division for this first couple examples, then we're going to switch to something called synthetic division for the next few examples. So polynomial long division works the same way as long division except with polynomials. So the divided by goes on the outside, the thing being divided goes on the inside. And what we do is we look at the first term here and the first term here. How would I turn an x into a 2x squared? Well, to turn an x into a 2x squared, I would multiply it by 2x. Sorry, that does not go there. It goes here because it matches. Now, let's say this was a third and then it went third to the x. We'd have to put in a space holder to hold the space, and I'll show that in a moment. But the 2x goes on top of the 6x because they're the same like terms. Then I have 2x times x gives me 2x squared. 2x times 5 gives me 10x. Now I'm going to subtract this. So 2x minus 2x is 0. 6 minus 10 is negative 4. And then you bring down the next term, negative 20. So now I want to turn an x into a negative 4x, and to do that I multiply it by negative 4. So I have negative 4 times x gives me negative 4x. Negative 4 times 5 gives me negative 20. And when I subtract that, I get a remainder of 0. So my answer is going to be 2x minus 4. Let's try another one. This one is written as a fraction, but we cannot divide this the way it's written, so we have to rewrite it as long division. Okay, to turn an x into a 3x squared, I need to multiply it by 3x. And then 3x times x is 3x squared. And then 3x times 3 is 9x. And then I need to subtract that. And that gives me negative 3x. Bring down the 5, so plus 5. I'm going to turn this x into a negative 3x, so I'm going to multiply it by negative 3. And that gives me negative 3x minus 9. And I'm going to subtract that, and negative 3 minus negative 3 cancels, but 5 plus 9, because that negative minus negative 9 is actually going to give me a 14. I can't turn an x into a 14, so I have a remainder. So because it's positive, I put a plus, and then whatever I was dividing by is my denominator. So that's how you write your remainders. So your final answer on this would be 3x minus 3 plus 14 over x plus 3. Okay. Now here's what I was talking about where we're going to need a space holder. I have x cubed, but I don't have any squareds or any x's. So I put them in with zeros because I need those spaces. So I want to turn an x into a cube. I need to multiply it by an x squared, so I needed that x squared space. So I will take x squared times x gives me x to the third. X squared times negative 2 gives me negative 2x squared. When I subtract that, I get 2x squared. Bring down my 0x and my negative 8. So you just bring everything down. Now to turn an x into a 2x squared, I multiply it times 2x. 2x times x gives me 2x squared. 2x times negative 2 gives me negative 4x, and then I'm not going to have anything to go there, which is fine. I subtract this, and the negative gives me a positive 4. And then to turn that x into a 4x, I multiply by 4. 4 times x gives me 4x. 4 times negative 2 gives me negative 8. And they match, so when I subtract that, I will have a remainder of 0. So my final answer will be x squared plus 2x plus 4. So you see, if you don't have an exponent term, you have to put it in there with a 0 in front of it as a placeholder. So you have to have every spot. So 3, 2, 1, none. You can't just skip from 3 to none, or it won't work. Okay, using synthetic division. When we use synthetic division, we look at this, what's going on. And first we're going to set the denominator equal to 0 and solve it. So in this case, we just subtract 5 from both sides, so x equals negative 5. We write that in a little box. The next thing we do is we take all of our coefficients, and if we're missing one, so let's say there was a third and then no squared, you put a 0 in. So you have to hold the space holders the same. But we have a squared, a single, and no x. So we write those down next to the little box with the 5. Okay. We skip a line, so we have room to write, and then we draw a line like that. Okay. The first thing we do is we bring down the first number, whatever that is. So that's a 2. Then, whatever we multiply or bring down, we're going to multiply. So negative 5 times 2 is negative 10, which gets written right here. So that goes up here. Then, on this row, top to bottom, we're going to add. So 6 plus negative 10 is negative 4, which I then multiply by negative 5, which gives me 20, and negative 20 plus 20 is 0. So what this tells me is these right here, these are my new coefficients on my answer. And the answer is going to be one exponent less than what you started with. So if you started with x squared, your answer is going to have an x. So it'll be 2x minus 4. If you started with x to the third, it would be x squared, x, and then nothing. So let's try another one of these. I'm going to take my denominator and set it equal to 0. So x is equal to negative 3, which I write in a box. Then I have my coefficients. So 3, negative 6, and 5, and I draw my line. Bring down my 3. Multiply by negative 3, which gives me negative 9, which I'm going to write up there. Negative 6 and negative 9 is negative 15, which I multiply by negative 3, which gives me a positive 45, and that gives me 50. So then what happened? Well, when I have that 50 there, that is a remainder. So I have to deal with the remainder now. And it's the same as when we had the remainders with the long division. We started with squareds, so we're going to have an x minus 15 plus, because it's positive, 50 over the thing I started with originally, x plus 3. So that's my answer. Okay, let's do a couple more with synthetic division just to get some more practice. Here I have the third. So again, I'm going to set my denominator equal to 0. X equals 2. Okay, so I put my 2 in the box. My first coefficient is a 1, so that's my x to the third. X squared, x, and then negative 8. So I have to have the same placeholders as I had when I was doing the long division. Okay, I bring down my 1. 2 times 1 is 2. Add it. 2 times 2 is 4. Add it. 2 times 4 is 8. Gives me a remainder of 0. So my new coefficients are 1, 2, and 4. So that would be my answer there. No remainder. Now, when I have this situation here where I have a 6, you're going to have to deal with a fraction. And that's okay, as long as you're comfortable with fractions. If you don't want to deal with the fraction, then you wouldn't use synthetic division, you'd use regular long division. So I'm going to take that 6x plus 1 and I'm going to set it to equal to 0. When I subtract 1 from both sides, I get negative 1. And when I divide both sides by 6, I get negative 1/6. That is what goes in the box. Then my coefficients are 6, negative 23, and negative 4. Well, that's constant, but draw my line. I bring down my 6. 6 times negative 1/6 is negative 1, because the 6's are going to cancel each other out. When I add those together, I get negative 24. Negative 24 times negative 1/6. 6 goes into 24 4 times. Negative 4 times negative 1 is positive 4. And I get a remainder of 0. So my answer is going to be 6x minus 24. Okay, here are your questions. When you have x plus 3 squared, does that equal x squared plus 3 squared, or x squared plus 6x plus 9? What does the FOIL stand for? So the F, the O, the I, and the L. When you divide a monomial by, or when you divide by a monomial, how do you write it out first? When you do polynomial division and you have exponent terms that are missing, what do you do? And then what is the first step to polynomial synthetic division?